Welcome to the second part of our series. So in this end-to-end series, we will be using Typescript to generate a complete full-stack web application. And during this process, we will be utilizing different libraries, tools, and we will cover several different aspects of development and DevOps. So in this particular part, we will be covering clean architecture, which is one of the popular architectures these days that allow us to organize our code files based on their functionality and hence improving our maintainability. Apart from that, there are other architectural styles like vertical architecture. We will be discussing those later. We will also be integrating MongoDB through Prisma ORM, and that will help us to integrate with MongoDB and several other databases. We will be using Mongo Atlas and some other online Postgres services. So the first step that we will be performing in this is like scaffolding our project and creating the folders based on the clean architecture guidelines. Then the second step that will be setting up our databases in online Mongo Atlas and similarly setting up an online Postgres database. We will be using MongoDB for this example, but we will also learn about writing the schemas for different databases. The third part is setting up the Prisma, and in this case, we will be downloading required modules, create a repository using Prisma clients that we have generated. We will also be pushing the schema to our online database services like NoSQL MongoDB and Postgres. So after that, as a next step, we will be writing the use case files that will be using our repository files. So after these use case files to create a decoupling from the database or Prisma code, then we will be writing services, controllers, and routes. So that is another abstraction layer we will be adding. Then we will move on to test application using Postman. So I like to do ESLint and Grafana before actually pushing the code. Our application.ts will be using routes. Routes folder will be containing all the routes, and routes will be internally using controllers, and controllers will be using services. Services will use use cases, and use cases will use repositories, and repositories will use the generated DB client to do our create, delete, update, read operations. The whole idea behind having so many files is maintainability and dividing the functionality in different files. So routes will be handling or mapping the HTTP request to controller methods, and the controller contain the files that handle the HTTP request and responses. The responsibility of services is to response formatting and error handling, preparing a proper response that can be sent out using the controller. Then we have the use cases, and the use cases actually are the actual business logic that will be implemented inside use case files, and it depends upon repositories, and repositories decouple them from actual database logic. So presentation layer has a middleware folder where we can actually place security related code like authenticating and authorization, or checking if the right person or right program is accessing the REST API, or that program or persona is allowed to perform certain operations. And then we have a validation to see if the data we received is correct. And then transformation, if we like to transform any kind of data, and across origin requests. They all go to middleware there. In infrastructure folder middleware, we place logging if we like to maintain application logs, any kind of error handling related classes or code, irrespective of language you are using, and then the transaction related code. So each folder has its own functionality. Then we have app.ts, that is the main file, and then we have the databases. We have to contain schemas, migrations, and auto-generated clients for ORM, and we will be generating Prisma clients. Let's start creating clean architecture folder structure in our scaffolded Express code. Our clean architecture folder structure and moved our bin file that was generated earlier on into source folder as well. So we have a source folder and 4 different subfolders: application, domain, infrastructure, presentation, as described earlier. And inside our infrastructure folder, we have 3 subfolders: database, middleware, and web. Database folder will be containing our generated Prisma ORM client, the Prisma schemas in Prisma folder, and repositories will be the TypeScript classes that will act as a coupling layer between our code and database code. The next thing we will be using are our domain, and there will be entities and interfaces. Interfaces will provide us with the contracts that will be implemented by our service classes and repository classes. Entities will be our classes, primarily data transfer objects on the application layer. Application layer will be containing the services and use cases by our presentation layer controllers. And then after controllers, the controller files will be used by our routes. This will allow us to install Prisma CLI and Prisma in our project. Once installed, we can have a look at package.json. We can find the dependencies. We will use npx prisma init to set up our project for Prisma, and it will generate two things: a Prisma folder and .env file. Env file will contain our connection strings, and then if you go inside the Prisma folder, we can find the schema. And also, we need to cut and paste this Prisma folder into our infrastructure database folder. We will be using MongoDB Atlas to store our NoSQL data. Instead of using the local containers or pulling MongoDB container from Docker's Hub, it will be one of the ways you can use to test your applications. The MongoDB Atlas provides us a free tier that we can use for testing and developing our applications. This free tier is free forever, and it provides 512 MB of storage, which is good enough for our small projects. So let's log into it. I already have account. If you don't have, you can create your own account and try it out. So I'll be logging in. You can always create a new project from projects that will allow you to provision a cluster for your database. I've already created one project here for my backend application. Here we have different options that allow us to browse any collections of documents and allow us to connect MongoDB in different ways. First, we have to find how we like to connect. At this point in time, we like to connect using native drivers, using a particular language. So here we can select what driver we need: Python, Node.js, and MongoDB, which is very popular one. So after selecting driver for a particular programming language, its version, here we can copy connection string and paste it inside our .env file. We can store all connection strings inside environment variables along with other variables that we need. We will be trying out Postgres schema how to use Prisma to create and push a Postgres database. We need a free online Postgres service, and Supabase provides us one for free for the small projects. And in this case, if you go to the pricing, it is free. Let's log into it. This is Supabase dashboard. I've already created one database that is hosted on AWS. So I can always create another project. I can select the organization and I can select any region here, give the project name. Below here, we have a number of different options. That's how we like to connect to database. In this particular case, we have two options. One option is like data API, which is very interesting, that we will be able to interact with our database with APIs working at PostgreSQL. Second is the connection string that we are using right now. After doing that, we can create our new project that will be hosted on AWS. Once inside the project, we can get our connection string from connect option, copy it to our .env file. So let's get into our infrastructure folder. Inside it, we have Prisma, and I created two different subfolders for different databases like MongoDB and Postgres. This is Prisma schema. Follow a particular syntax. We need slightly different schema as compared to a relational database. MongoDB is a document database, so it needs different attributes here. In the top, you can see that we have a client, generator, client. We are mentioning the provider. We'll be using Prisma client.js. Once we generate a client, the output will be stored in generated MongoDB folder. If we go below, we can see that this particular schema will be using a MongoDB provider, and it will pick a connection string from our environment variables .env file. We can see different document collections like products, customers, order, and order items. In product, you can see different items like call code, name, vendor, description, stock in quantity, buy price, retail price, creation date, modification date. Their types, there are certain types that are supported by Prisma schema at the moment, and you can consult documentation for that. It involves string, integer, float, datetime, and some others. Thing we see here, they are called attributes and they start with @. Here we are saying that this product code is an ID, and by default it is auto-generated. We do not need to pass in while creating the product. After that, we have a map. Because document collections have their own way of storing the IDs, so this particular ID product code will be mapped to document collection underscore ID. If we have a look at other attributes, we can see that date and time modification has @updated at. This attribute specifies that whenever data is updated or created, current date and time will be stored. Other attributes here, like for creation date, whenever product is created, by default, creation date will get the current time. There will be two different ways to store data. One is embedding the data in the same document collection, like storing all the order items inside order as a sub-collection. Or we can always store object IDs of order items in order to access relevant order items from the order document collection. In Prisma schema, we have to put a counter relation. If we have many order items for a product, then in order items, we have to specify a relation that can actually map product ID to product code. Then we have the index. So we'll be indexing on product name. Indexes are the key way to improve the performance of NoSQL and SQL databases. So for the second document collection, we have the customer, which is pretty similar working, and we have given at unique attribute that no other customer can use the same email address. I have created a schema file here. It is quite similar to MongoDB, and it has the provider, which is same Prisma client JS, and then generated Postgres is a separate folder to place generated Prisma client for Postgres. Product entity is quite similar. This index here on the product. If we like to define indexes to make our queries faster, then it can be done through Prisma schema by using @ index attribute and specifying the field on which we want to generate database index. For this relational database, we have created like product table, customer, and we have also defined one to many, many to many, one to one. We can define many to many by introducing a join table, try to generate schemas, and then to push database. Now let's generate Prisma client by using npx Prisma generate command and providing the schema. We have generated Postgres client. Now let's try to generate Mongo client. So running the command again, we can find Prisma client code in database generated folder. Now let's push MongoDB schema to Mongo Atlas Online using the CLI command. MongoDB VS Code plugin allows us to connect to Atlas MongoDB instance like a local Docker's container. So here we can provide the connection string, or we can open a form to provide the connection information to connect to our remote database. In this case, we have provided the connection string here, and it allowed us to connect to our database. We can also go and check different documents in our document collection. Now let's use Prisma migrate command to push our schema to online Postgres database. After migration, we can check tables online. I'm not using this tool at the moment, but it's very interesting AI tool to generate schemas for different databases. It provides us to select different models and providers to generate schema and gives very interesting results. So I'll be testing a very small prompt here. Generate Prisma schema for student registration. Generate. Wow, it's interesting. It has generated a complete Prisma schema for us. We can change these attributes and things if we like. So world is changing now. Visual schema generators. This can help you to generate your schemas very quickly. Schema Visualizer is one tool, and the other tool is Prism Builder IO, and you can find many others that allow you to create Prisma schemas. Setting up ESLint help us during development by enforcing coding standards and preventing common errors early in the development process. It also helps in improving the code quality by ensuring best practices. Now let's run nps ELint init. Responding to different questions during ELint setup process. We will further explore ESLint usage in code review. Now let's start reviewing the code. Let's explore domain folder that has entities and interfaces. Let's start with customer file where we have created a customer class to serve as data transfer object based on the Prisma schema. Most of its fields are pretty common, like customer code, name, email, with their strong types, and it other classes like order to meet schema requirements and allow easy access to orders. One customer can have many orders. Then if we go to orders class, it is pretty similar. One important thing to note here is that we have provided all the fields in constructor. That is a syntax ease provided by the Typescript. We are not actually creating any fields in the class body, but these fields will be created automatically. And apart from that, we have the relation fields that will allow us to access other related entities when required. Like customer ID is required to get the customer. And if we go to order items, we can see that it has order item ID quantity status for this example, and relation fields like order ID and product ID that shows that to which particular order or product this order item belongs to. Many customers can place different products, and for each product we can have many different orders. Let's explore interfaces here. And in interfaces are the contracts that our repository and service classes will be implementing. So it's a design by contract approach. And for the iCustomer repository, what we have here is find all, find by ID, find by name, create, update, delete, and find by ID with orders. These are the signatures for the contracts. With find all, return as a promise a customer array or a null. By ID, we will be sending in the customer ID and it will return us the customer object. Then by name, we will be sending in the customer name and get the customer array because there could be more or many customers with the same name. Next is create, update, and delete. Common use cases for find by ID with orders. We will be passing in the customer code and that will return the customer. In this services section, this is the contract for the customer service, and it has similar methods: get customer by ID, by name, and for create customer, update, and delete customers with specific method signatures for input and return values. And all of them have null or return a single object and sometimes returning the complete array. So that we can find all the orders placed by a customer by this last method, and this is the signature for that method. We will be implementing it in our order repository. Similarly, we have implemented similar interfaces for customer and order repository. Let's walk through the repositories folder. I created 3 repository classes here: customer, product, and order. There are 2 factory classes. One creates Prisma client that we need to interact with database. Second one creates and returns object of repository. It can be either product, order, or customer. Let's go to the Prisma client factory. On this side, we are importing index files from MongoDB and Postgres generated clients. At the top, class Prisma client factory. It has private member, a client that can be of MongoDB, Postgres, or null type. And after that, we can see that we have 2 different methods to return client or based on the database type, like get MongoDB client and similarly Postgres DB client. Here internally we create or instantiate MongoDB client object, or in case of Postgres server we pass in the environment variable that contains the connection string and it returns the instance of the Postgres DB client that we generated using this Prisma generate CLI. Let's visit one of the repositories. In the top section, I have imported required entities, interfaces, and Prisma factory classes. And the second step is to get an instance of MongoDB client. Here, we are doing that. The third step, here we are actually implementing the iCustomer repository interface to do our operations with the database. So we have all the find all, find by ID, find by name, create, and if you go below, we have update and delete and find by ID with orders. So we are implementing these contract methods and returning customer array or null based on requirement. In the find all, we are calling find many using the client db.customer.findMany, and then after that we are returning the customer. It is good to implement exception handling here that we will do later. If you go to the second method here, providing customer code as a string and using the find unique Prisma client method that passes in a JSON key where and the value contains the customer code. This method returns a promise that is a customer. In case of failure or if it doesn't find anything, null will be returned. And it should be handled in the calling method. And similarly, we are implementing a find by name using a find many method of the Prisma client. And then the create method, we are passing in the complete customer entity that is already filled and calling the Prisma client create method to pass in the JSON that will allow us to create a MongoDB document. And we are also returning the newly created customer back as a convention. And here we have implemented try and catch as an example. Update method that is quite similar to create method. Here we pass in the customer code, which particular document we want to update, and the customer entity. It promises a return of the customer. And then there is some code here that I just want to comment out that I use for debugging this section. Then we are using the where clause to find. The update, we are using the where key value to find and also sending in the data that we want to update. And finally, we are returning the newly updated customer or null. In the delete, we are just passing in the code with the customer ID as a string, and we call the delete method on our Prisma client. This is an interesting method where we are returning customer and all orders of that particular customer. We have provided where along with the value that contains the customer code, and it has include that sets order true, which tells the Prisma client that we have to fetch all the orders that belong to this customer. And if we go to, if we observe that we have this red mark here due to elinting, elinter, it's not a syntax error, but we are using the order entity here and importing it, but we are not using it anywhere. So ESLint is telling us that this particular import is of no use and it is not being used anywhere. Order repository, it has the similar implementation, just like what we have done in customer repository. And similarly, we implemented the product repository and it implemented iProduct repository contract. Finally, we have another factory that is the repository factory that imports all of the contracts and the repositories. And the objective of this factory is to provide an object of the repository class. It has three methods for each of our customer repository and order repository and product repository. Get customer repository returns an instance of customer repository, and this factory method will be helpful for us to getting instances of different repositories when we will use it in our use cases. Now let's visit our application folder, and under that use cases. Use cases will be using our repository files that we created, and especially the repository factory, and it will get its instances. So we have a lot of use cases here. Create customer use case, create order use case, create product, delete customer, delete order, delete product, get all customers, and so on. One question can be that why we are having so many small files, and what is the need of this particular use case section. Use case files makes it easier and have several different benefits. One is adherence to clean architecture, and second is easier maintainability and code organization. And moreover, it gives an opportunity of improved testability, and it is easier to write test cases. We can reuse these use cases in several different places the way we like. So they are more granular and cohesive parts for database interaction that can be used, and they can be composed together to achieve other objectives in the services. Let's walk through create customer use case. In the top, we are importing customer entity and then the iCustomer repository. And at the third line, we are importing repository factory. The use case class itself is class create customer use case, and it has a private member that is customer repository, which is an instance of iCustomer repository. Then in constructor, we are initializing this customer repository using the repository factory and by calling a static method getCustomerRepository. And the only method this class has is execute method that takes in customer. It is async method, and it promises to return a customer or null. If the customer is successfully created, the same customer will be promised. And here we are calling the create method on repository and passing in the customer data. Similarly, we can have a look at other methods, like if we go to delete customer here, it is quite similar and doing the similar thing, except that it is passing in an ID string. Customer or null is expected as a result. It calls the delete method of the customer repository. All the use cases are implemented in the similar fashion. Any code at this level is not dependent directly on database, and it is totally decoupled from the database code. It can be reused with a Postgres schema as well. We are creating instances of all use case class objects that belong to customer service, and there is a corresponding method in customer service class that actually invoke particular use case by passing in the required parameters. So it is just simply delegating different calls to different use cases. And all the order and product services are based on the same pattern. Now it is time to visit our controllers in presentation. Controllers prepare our responses and receive the responses from our web. This is the layer between our web layer and our application. It uses service classes to perform different tasks. And here we have different methods like get all customers, get customers by ID, which are quite similar to the service class. But the difference you can see here is that it receives a request from the web, and it is responsible for preparing the response for the web. Here we have a try catch, and you can see that there is an underlined error here. It is linting that is telling us that error is not being used anywhere. It is not a syntax error, it is a linter error, and we can correct it by properly utilizing this error object. We get an array of objects when we call the services class. We are passing in the customer object that is converted to JSON in this case. So we can also pass the status information like 200 or anything else here, like dot status. We have order controller and product controller. They achieve the same functionality for us. Let's go to routes now. Controllers will be used by our route classes. For customer route, it is the point where we are mapping our URL route to our customer controller method. Here we have router.get that contains this last part of our endpoint /:id. So we'll be passing id as a part of URL. And second parameter is an anonymous function that calls customer controller.get customer by ID and pass in the request response. And we have written numerous other endpoints and method mappings using the same pattern. That remains true for order and products as well. And let's, as a last part, let's have a look at our app.ts now. In the top, we have imported express, path, cookie parser, logger, .env to parse our .env file, body parse to parse request bodies to extract our entities in case if you want. And then we have product routes that we just created and customer routes and order routes that we imported into our app.ts. And then we have constant app express, and we are adding the middleware and like logger and express JSON. And we are using URL encoded module here, and then we are using body parser, cookie parser, and method override. At the end, we are using our routes, like the main part of a route will be /API/product. If I have stivaso.com, then /API/product, that will be the first part of our URL, and second part of our URL will come from here, as we described earlier, from our controller, from our router. The second part of the URL will come from our router here, /:id. We will be testing our code using Postman, which is quite popular for testing REST APIs and GraphQL or gRPC. Now it is time to test our endpoints. I'm using Postman desktop application. And here we have created a collection of tests, and start with a completely blank collection like this and name it something backend TS. You can add a request and provide, in my case, I'm providing customer, selecting the get method. In this case, I like to get all the customers. I'm sending. It should return all the customers. Here we are getting all the customers. Let me copy this part of my request and create another endpoint. So in this case, I need to bring back one of the IDs. I'm providing in the path variable, and let me get one of the IDs. Now I want to get this specific customer, and it's there. I need to add another request. In this case, it will be a post request, and the URL is same. And I would like to create a new customer, so I'll go to body, and here I'll select raw. Let me copy one of the earlier responses, change it to recreate a new customer. So I'll be deleting this part. It is auto-generated. And maybe something like this. So I don't need these fields. So let's send and see if we can create a new customer. Customer created successfully. So we can test it with a new request. So in this case, let's send the request and see if the new record is created. It's there in the collection. So what if I like to delete it? For deleting, let's try this pre-created one. In a similar fashion, we created this one. I have the delete selected here, and then the URL and a proper parameter. In this case, we like to delete the document we just created. So customer deleted successfully. Now we like to update one of our customers. I like to change it like this. Copy paste. Like I'm copying the original document. Pasting in the raw and changing the fields I like to change. For Mac ABC, and I'm changing this to 4444 Main Street. I don't need to pass in this here. So customer updated. Let me get all the customers. So here we have changed it, and this one as well. Our next step will be adding security in our REST backend API. And we also need to scale it and provide some mechanisms to add live monitoring using tools like Grafana. There are several different ways to add scalability and security in the application. So this is end for this video, and stay tuned for next video.